Hello, everyone. So, this is the eighth week in this session on solving gate physics problems. And this week, we will be focusing on some problems in quantum mechanics. So, as always, we will start with a few questions in general aptitude and then we will move towards quantum mechanics. So, let's get started. So, first up, we have some comprehension questions in general aptitude. So the first question over here says that the nomenclature of Hindustani music has changed over the centuries. Since the medieval period, Dhrupad styles were identified as banis. Terms like Gayaki and Baj were used to refer to vocal and instrumental styles respectively. With the institutionalization of music education, the term gharana became acceptable. Gharana originally referred to hereditary musicians from a particular lineage, including disciples and grand disciples. So now this is the passage that we are given, and we have the question says, which one of the following pairings is not correct? So we have these bunch of options. So the first option is Thrupad and Bani. Well, this is a correct pairing because in the passage it is given that since medieval period, Dhrupad styles were identified as Banis. So that is correct. The next option is Gayaki and vocal. That is also correct because Gayaki is used to refer to vocal styles. It is given in the passage. The third one is Baj and institution. This is not correct. So this is the option that we are supposed to select. Why? Because Baj refers to instrumental styles and Gharana and lineage are again a correct pairing. So this was a small passage on Hindustani music. It would be nice if people can listen to some Hindustani music. That would give you some flavor of what it is all about. So moving on to the next question. This is a simple question based on some simple mathematics. So the question goes like, two trains started at 7 a.m. from the same point. The first train traveled north at a speed of 80 kilometers per hour and the second train traveled south at a speed of 100 kilometers per hour. The time at which they were 540 kilometers apart is, and we need to select the correct option. So pretty simple question. Let us look at it. So train A is having speed 80 kilometers per hour and it moves northwards. Train B is having speed 100 kilometers per hour and it moves southwards. So if we look at relative velocity of B with respect to A, of train B with respect to train A, that would be what? That would be 180 kilometers per hour in the southward direction. So now if this is the speed, then it will cover 540 kilometers in 3 hours. Why? Because it covers 180 kilometers in 1 hour, so 540 kilometers in 3 hours. So 3 hours would mean that the time is 7 a.m. plus 3 hours, which is equal to 10 a.m. So the correct option is 10 a.m. At 10 a.m., the two trains would be 540 kilometers apart. Next question. This is some logical reasoning type question. So the statement that we are given is some students were not involved in the strike. If the above statement is true, which of the following conclusions are logically necessary? So when we are talking about something being logically necessary, we just have to work our way by looking at the logical facts. We don't have to interpret it in our own way by trying to apply our own interpretations to it. So the statement is that some students were not involved in the strike, and we are given these four options, which are the logical conclusions from this. First one says some who were involved in the strike were students. Next option says no student was involved in the strike. Third option is at least one student was involved in the strike. And the fourth one says some who were not involved in the strike were students. So if you could just write in the chat box what you think is the correct option from the options A, B, C, and D given, it would be very nice, and then we will proceed further. So, okay, someone is saying B. Okay, other people also please respond. I'll wait for a minute and then we will proceed. Okay, fine. So, let me explain this. So, let me first tell you what the correct option is. Then I will justify why that is the correct option. So, correct option is option C. Now, let me tell you why this is. So, let us say we have a set. So, this is a set of students. Okay. Out of this set of students, so this is the set of students. Out of this, what we are told is that some students were not involved. So let us say these are the some students, and these are basically not involved in strike. So this is what you have basically pictorially. If we represent it in terms of sets, this is what you have. So you have the statement that we are given is that some students were not involved in the strike, meaning that there are a few students, and out of that group of students, some students are not participating in the strike. Now notice it does not say anything about the other students, whether they are involved in the strike or not. It does not say anything about that, the given statement. So this is the given statement. It does not say that some students were involved and some students were not involved. It is not that kind of a statement. So from this, what you can only conclude is statement 4, which says that some of those people who were not involved in the strike were students. So if there is a strike happening and there are some people who are not involved in the strike, then we can say that some of those people are basically students, because this is what the statement says, that some students were not involved in the strike. So if you have if you divide the number of people that you have into two groups, group 1, which is the group of people involved in the strike, and group 2 is the group of people not involved in the strike, then in group 2 you will have some people who are students. So if I make another set, let's say this is my set of people, and this is my people who are in the strike, and this is the people who are not in the strike. So in this not in the strike, you will have basically some students who are members. So from the group of students, you will have some students who are in this group which is not involved in the strike. So this is the only correct statement and the only logical conclusion that you can draw from the given statement. You do not have to put in your own interpretations and think, okay, fine, some students were not involved in the strike, then maybe some students could have been involved in the strike. You cannot draw conclusions like this. You have to go very factually and based on exactly the statement that is given to us. So this is the correct option. Moving further, the fishermen dash the flood victims owed their lives were rewarded by the government. Again, a very simple grammatical question. So again, if people can just type in the chat box what they think is the correct option, then I will tell what the correct option is. Very simple grammatical question. This is. So the sentence the correct option in this case would be the fishermen to whom the flood victims owed their lives were rewarded by the government. So it is not fishermen whom the flood victims owed their lives. No, that is not correct. It is not the fishermen to which the flood victims owed their lives. That is also not correct. Uh, and that is also not the appropriate word over here. The appropriate phrase is the fishermen to whom the flood victims owed their lives were rewarded by the government. Next question is another simple mathematical type question. So we are given that x squared plus x minus 1 is equal to 0, and we are supposed to find out the value of x to the power 4 plus 1 over x to the power 4. So let us start. So we have x squared plus x minus 1. This is equal to 0, which implies x into 1 plus x. So basically, I'm just taking stuff common. So let me first go step by step. So x squared plus x is equal to 1, which implies x, taking x common, and then we are left with x plus 1. This is equal to 1. So this gives me that x plus 1 is equal to 1 over x. That means x minus 1 by x is equal to minus 1. Now from this, if I square this, what will I get? X minus 1 by x whole squared is equal to x squared plus 1 by x squared minus 2. And on the right hand side, minus 1 squared would give you 1. So this means that x squared plus 1 by x squared is equal to 3. And from this, if you again square it one more time, you get x squared plus 1 by x squared whole squared is x4 plus 1 by x to the power 4 plus 2. And on the right hand side, 3 squared is 9. So this gives you x to the power 4 plus 1 by x to the power 4 is equal to 7. So 7 is the correct option. So this was the section on general aptitude, some few very simple questions. Now we will move towards some questions on quantum mechanics. So I hope all the Hamiltonian operator for a two-level quantum system is given by H is equal to E1, 0 and 0 E2. This is a 2 cross 2 matrix for a two-level quantum system. Then the question is, if the state of the system at t equal to 0 is given by, we are given that the state is given by psi 0 is equal to 1 over root 2 and 1, 1. Then we need to find out this particular probability of the state at certain time t. So we need to find out this expression at a later time t. So how we will do that? Let us get started. So first up, what we are given is, we are given this initial state vector. So that means initial state vector is like a superposition of the particle being in the system, being in the eigenstate with energy E1 and eigenstate with energy E2. So if you just write down the eigenstate for E1, so let us say psi in for eigenstate in energy E1, that would be 1, 0, and psi for the energy eigenstate E2, that would be 0, 1. So this particular initial state is like a superposition of these two states, which are for energy eigen value E1 and E2 respectively. So that is the initial state, and then at certain time t, we will have the time evolved state, and what that would be given by as follows. So time evolution is given by this operator, that is e to the power minus I e t over h cross. So for the first one it is e1, and then for the second one it is e2. So this is my psi at time t, and then if I look at that particular probability that we want, the transitioning from t equal to 0 to some time t. So this would be, so 1 by root 2, 1 by root 2 from both, that would be half, and then taking square of that half is 1 over 4. So 1 over 4, and then what you have is e to the power minus I e1 t over h cross times 1. So that is this, plus the second term, that is e to the power minus I e2 t over h cross times 1. So that's that. So this is the thing. Let us simplify this. So we have 1 over 4. This mod squared means complex conjugate times itself. So it is e to the power I e1 t over h cross, taking the complex conjugate, plus e to the power I e2 t over h cross, and then e to the power minus I e1 t by h cross, plus e to the power minus I e2 t over h cross. So let us simplify further. So this is 1 over 4 1 over 4 times, so let us just multiply it, open the brackets, so we get 1 plus e to the power I e1 minus e2 t over h cross, plus e to the power I e2 minus e1 t over h cross, plus 1 again. So this term, this is like a complex conjugate of each other. So this gives me 2 times cosine e1 minus e2 t over h cross, and this whole thing is inside the cosine. So what you get is 1 by 4, 2 plus 2 cosine of e1 minus e2 t over h cross, this whole thing inside the cosine. So finally, taking 2 common, we get 1 over 2, 1 plus cosine e1 minus e2 t over h cross. So this is the correct option, option C. Now coming over to the next question. Consider the motion of a particle along the x-axis in a potential given by V is equal to F of mod x. Its ground state energy E naught is estimated using the uncertainty principle. Then E naught is proportional to, and we need to find out E naught is proportional to what power of F. F being this factor in the potential that we are given. So the energy for such a situation, so energy is what? It is kinetic energy plus potential energy. So energy is kinetic energy plus potential energy, and kinetic energy is p squared by 2m, and potential energy is this v that we are given. So v is f of mod x. Now if we open the modulus, then what we get for x greater than 0 and minus fx for x less than 0. So this is the energy that we have. Now from the uncertainty principle, what we have delta x delta p is equal to h cross. So notice that we are just supposed to find out the proportionality in terms of the powers of f. So order of magnitude is what we are looking at. We are not looking at the precise numbers next to it. So you might be saying that this should be h cross by 2, let us say. Well, that is fine. That is just a constant factor of half. It is still of the order of magnitude of h cross. Like in terms of h cross, it is not like 100 times h cross or something. So it is of the similar order of magnitude, and what we are interested in is in the powers of f. So for that, whether you write h cross by 2, it's just a constant number, and that doesn't really make much of a difference. And again, why we are taking this equality? Well, we want to just find out the factor. It will be greater than equal to, that would be the thing, but we are just interested in trying to find out the order of magnitude, and that too for the minimum energy, that is for E naught. So in that particular case, we are just writing down that order of magnitude for the uncertainty is of the order of h cross. So that's how we have written this. So this gives me that delta P is h cross over delta x. So putting this in the expression for energy, we have energy is delta P squared by 2m plus f of delta x. And this gives me, now substituting this, so this gives me h cross h cross squared by 2m delta x squared plus f times delta x. Now for minimum energy, that is for ground state. So ground state is like it's the minimum energy. So ground state means minimum energy. And minimum energy is found by differentiating this expression for energy with delta x and setting it equal to 0. So this gives me, differentiating with respect to delta x, so h cross squared by 2m is the factor, and then you have minus 2 over delta x cubed plus f is equal to 0. So from here, we will get what delta x is. So 2 cancels out. So this gives me that delta x is equal to h cross squared over mf to the power 1 by 3. So this is what I get for delta x for minimizing my energy. And now we can put it back in the expression for energy to get the minimum energy. So substituting the value, so h cross squared by 2m, and delta x is h cross squared over mf to the power 1 by 3, and then squared, that would make it 2 by 3 plus f delta x So simplifying it, we get h cross squared by 2m mf by h cross squared to the power 2 by 3 plus f h cross squared by mf to the power 1 by 3. Now, if you look at the factors of f, so you have one factor of f over here. So this is f to the power 2 by 3. And then you have another factor of f. So this is f to the power 1. And then you have 1 by 3 in the denominator. So 1 minus 1 by 3, which is again f to the power 2 by 3. So from this, you get that E naught is proportional to f to the power 2 by 3. So now notice that if we had just written over here instead of h cross by 2, then what that difference would have, what the difference it would have made is just these factors of 2 here and there. So you have h cross squared by 2m and all these factors are there. So you would just have an additional factor of 2 and some powers of 2 here and there. But what is important is the order of f, and that would be the same. So order of f is f to the power 2 by 3. So the correct option is option D, f to the power 2 by 3. So next question. The wave function psi x of a particle is as shown below. So you are given this wave function. Here k is a constant and a is greater than d. So we are supposed to find out the position uncertainty of the position uncertainty delta x of the particle. So this is the wave function that we are given. So if we write down the expression for the wave function psi of x, so psi of x is having the value k in this interval. So this interval, so it is k when we have the following condition. Then it is 0 in this part, 0 over here. So 0 when you have minus a by 2 plus d by 2 to a by 2 minus d by 2. And then it is k again in this region. So this is a by 2 minus d by 2 to a by 2 plus d by 2. And then it is 0 beyond these intervals as well. So it is also 0 for and x greater than a by 2 plus d by 2. So this is the mathematical expression for the wave function. Now we can find out the value of k by normalizing the wave function. So normalizing it, so it is k in the domain minus a by 2 minus d by 2 to minus a by 2 plus d by 2, and also in the domain a by 2 minus d by 2 to a by 2 plus d by 2. So this is the domain. And then just substituting the values. So this gives me k squared x. So integral of 1 is just x, and this is going from minus a by 2 minus d by 2 to minus a by 2 plus d by 2. And the second term is also x, but for a different interval. So now just plugging in the values. So this is this, and then if you notice that a by 2 terms cancel, so minus a by 2 and then minus minus plus a by 2, then a by 2 minus a by 2, this cancels. So you are left with k squared, and then each of these d by 2 comes with a positive sign. So k squared, and then you have 4d by 2, that means 2d. So this gives you that k is nothing but 1 over square root 2d. So you get the value for k. Now we see that the wave function is symmetric about this, symmetric in x about the origin. So wave function is symmetric in x. So what this means is that expectation of x will be 0. That is average value uh, or expectation value for x in this case will be 0. Half of it is in the positive x direction, half of it is in the negative x direction, and it is perfectly symmetric. So you get expectation equal to 0. You could do the integral also, and then you will see that the positive and negative halves cancel out perfectly. So you get expectation of x equal to 0. So next we will find out the expectation of x squared, that is this expectation. So this expectation, now let us find out. So this expectation is what? This is basically uh, x squared psi x dx. This is how you would find out. So that would be, sorry, this is x squared. So basically this is like psi star x squared psi x dx. This is what you would do. So find out the expectation, and then the psi star psi will give you k squared. So you have k squared, because this wave function is just like a constant wave function, but it is constant for it is having different constant values in different regions. So it is having value k squared, sorry, k, and then if you do psi star psi, you get k squared. So this in the interval minus a by 2 minus d by 2, 2 minus a by 2 plus d by 2, and then x squared dx, plus another interval where the wave function is k, and that is a by 2 minus d by 2, 2a by 2 plus d by 2, x squared dx. So what you get is k squared, and then x squared integral is x cubed by 3. So take 3 common, and then x cubed for a particular interval, and then x cubed again, but for a different interval. So let us now simplify this. So what you get is k squared by 3 So minus a by 2 plus d by 2 cubed minus of minus a by 2 minus d by 2 cubed plus a by 2 plus d by 2 cubed minus of a by 2 minus d by 2 cubed. Now this 1 by 2 you can take common, and 1 by 2 cubed is a or 1 by 8. So what you will get is take 1 by 8 common, so 3 into 8, and then you are left with minus a plus d cubed sorry, not squared here, this is cubed, and then now you can use the formula for a cubed minus b cubed or a cubed plus b cubed. So let us put that. So first one, that is minus a cubed plus d cubed minus 3a squared d plus 3a d squared. Now this is minus, but inside the cube is also, it is minus. So minus 1 cubed is minus 1, and that minus becomes plus. So this you will get as plus of a plus b whole cubed. So a cubed plus d cubed plus 3a squared d plus 3ad squared. Then the next term, this is also again a plus d cubed. So same thing again. Plus the last term. So that's a cubed minus d cubed minus 3a squared d plus 3a d squared. So now let us simplify further by taking terms common. So let us group together terms which are similar. So let us see if some things cancel out or not. So 3ad squared here, 3ad squared here, 3ad squared here. Okay, 3ad squared is I'm not sure if I have done all the arithmetic properly. If I'm missing out, this is just pure arithmetic actually over here. So it seems that what I'm getting is, okay, let me just revisit this arithmetic. So here there is a minus a cubed and that then a plus a cubed over here. So that means for a cubed we are left with 2a cubed. Then for d cubed here, d cubed here, d cubed here. I have this 2d cubed cancel, so that gives us with 2d cubed. And then for a squared d, so a squared d minus 3a squared d here and plus 3a squared d, this cancels out. And then 3a squared d here and minus 3a squared d, that also cancels out. So for a squared d we have 0a squared d. And then for ad squared, okay, ad squared, this is 3ad squared here, 3ad squared here, 3ad squared here, and another 3ad squared here. So that makes it 12ad squared. I think I'm missing out something somewhere. But anyway, let's proceed. So this is k squared. Now we can take 2 common. So that makes it as following. And now we can plug in the value of k. So k is this thing right here. So k squared would be 1 over 2d. So 1 over 2d, and then we have 12. So this is their value for expectation of x squared. Now delta x is nothing but expectation of x squared minus square of expectation of x. Now this we know is 0 by symmetry. So this is simply as follows. And that means square root of this thing right here. So if you go back to the options, I think I have done some sort of an arithmetical error in this step. I think in this step, I think I'm missing out some arithmetical because I'm getting 3 terms over here, but the options have at most 2 terms. So somewhere I'm making a mistake. I think this a cube term is where I'm making a mistake. This term should not have been there. Then only this d in the denominator and some d factors in the numerator will cancel out, giving us something which looks similar to the options given over here. But I'm not sure as to exactly where I have made that some plus minus error. Something I have uh, done wrong. So can anyone point out some arithmetical error over here? Otherwise, I will fix it up in the next class. So can someone quickly see if there is some sort of arithmetic error in trying and combining the terms over here? If someone can tell me where it is going wrong, then that would be really helpful actually. I think here I have made the error. Okay, fine. This part, this thing should have, this is negative. Yeah, here I have made the error. So let us fix it here itself. So this thing was negative over here. See this negative sign, this negative, and I made it positive over here. I don't know why. So this is negative. So now let us recheck everything. So minus a cubed plus a cubed and a cubed minus a cubed. That gives me with 0 a cubed. So this factor is 0 a cubed. Then you have d cubed, d cubed, d cubed, and minus plus. That means 4d cubed over here. So this is 4d cubed. Then let us look at a squared d. So minus 3a squared d plus 3a squared d, that cancels. 3a squared d and minus plus 3a squared d, that makes it 6a squared d. Okay, again, let us be very careful. And then ad squared. So 3ad squared, 3ad squared, 3ad squared, and minus 3ad squared, that is 6ad squared. I hope this time it is correct. So what we have is uh, I think still somewhere I have gone wrong, in the sense that I should have gotten only a squared d term, only then this d in the numerator and denominator would cancel out to give me some form of this. Maybe we will come back to this plus minus sign later. I think I've messed up some plus minus signs. But the point is that this is the expression for delta x, and this is how you would proceed apart from the arithmetical error that has been made over here. So we'll fix that either at the end of this lecture or maybe in the next lecture. So moving further, we are given that we have states psi 1 given as 1, 0 and psi 2 given as 0, 1, which represent two possible states of a two-level quantum system. The state obtained by the incoherent superposition of psi 1 and psi 2 is given by a density matrix which is defined as follows, and we are given the values for C1 and C2. Then we need to find out the matrix element row 2, 2. This is very simple. See, matrix element row Mn is given as follows. Sorry, not psi Mn, psi M and then psi n over here. So this is the matrix element. This is how you would get. Now for 2, 2, what that this would be psi 2 row psi 2, and very simple. So this would be C1 psi 2 psi 1. So C1 is just a constant, C2 is also just a constant. So like so. Now since psi 1 and psi 2 are orthogonal, this is 0 and psi 2 is also normalized, so this is 1. So what you get essentially is simply C2, which is 0.6. So the answer is 0.6. And if you write down the complete density matrix, then this is very simple. This is an incoherent mixture. So for incoherent mixture, this is how you would have the density matrix with terms along the diagonal. So you would have these terms along the diagonal, and the off diagonal would be 0. So this is how you would represent the density matrix for any incoherent mixture. Moving over to the last question. So a two-state quantum system has energy eigenvalues plus minus epsilon corresponding to normalized states psi plus minus. So it is plus epsilon for psi plus and minus epsilon for psi minus. At time t equal to 0, the state is in the quantum state given as follows, which is a superposition state of psi plus and psi minus. The probability that the system will be in the same state t at the time t equal to h over 6 epsilon is we are supposed to find out. So again, very simple. It is again based on time evolution operator. So what we have is psi 0 is as follows. And then psi at time t would be this. Why? Because the time evolution operator, time evolution, we saw this in a previous question also, is given by exponential minus IE t over h cross. So now at time t equal to h over 6 epsilon, what you have is as follows. So 1 over root 2 minus I epsilon over h cross, and t is h over 6 epsilon. So this minus and minus makes it plus. Again, just simplifying. So h is nothing but h cross times 2 pi. So this is h cross times 2 pi. So terms cancel. So h cross cancels with h cross, epsilon cancels with epsilon, and then 2 factors out 3 over here. So what you get is as follows. So this is the state at the particular time that we want, and probability is given as follows. We had seen in one of the previous questions as well. And just for the normalization, we have this, but we are given that this is already normalized. So we don't need to worry about that. So that means this is psi t is over here, and psi 0 is given. Sorry, this is not psi 0, this is psi t only, and psi 0 is given over here. So if we write down, then we have this is the ket, the bra for the psi t, and then the ket for psi 0. So this gives me, so 1 by root 2, 1 by root 2, that's half, and then square of it, that gives me 1 over 4. And then we are given that these are these states are basically normalized. So this normalized states, and they will be orthogonal because they correspond to different eigenvalues we are given. So in that sense, what you have is this term would be 1, and this term would be equal to 0. So if you put that in, what you would get is basically like so. And this is nothing but 1 over 4, and this term is 2 cosine pi by 3, and then square of that. So this is cos pi by 3 is nothing but half. So that is 1 over 4, and this is 0.25. So the answer is 0.25. So simple question based on the time evolution. So the important thing in this question has been just this time evolution operator, and then writing down the probability like so. So this is the important aspect. So this basically concludes this week's session on quantum mechanics and general aptitude. The only issue that we have faced today is some arithmetical problem over here, something plus minus went wrong, but other than that the concept is correct, in the sense that this is how you would proceed. So x squared expectation would be given like this, and then this is how your uncertainty in x would be given, and if you have something which is symmetric, then the uncertainty in the position would be 0. So sorry, the expectation of position would be 0. So this is how you would get the uncertainty in position. Now I'm just not able to figure out where I have made this plus minus error. One error I saw that I had done, plus minus thing had gone wrong over here. If someone can just see where something is going wrong, just some arithmetic somewhere here and there has plus minus sign, I think somewhere I've messed up. So if someone can just help me in that. I think here this sign is wrong. So this is what? D minus a cubed, right? So if I just write down d minus a cubed, first term is d minus a cubed, so that is d cubed minus 3d squared a plus 3d a squared minus a cubed. This is what it would be, right? So this is d cubed, correct, minus a cubed, correct, and then this should be a squared, d should come with a plus sign, and minus ad squared, and ad squared should come with a negative sign. So this thing, so this also some error was here, plus minus gone wrong. Yep, you should be very careful with this sign plus minus thing going here and there. I think now everything is fine. Okay, now if I look at it, so minus a cubed plus a cubed, that cancels, a cubed minus a cubed, that cancels, then d cubed here, d cubed here, d cubed here, and d cubed here, 4d cubed, then a squared d, so 3a squared d, 3a squared d, 3a squared d, and another 3a squared d, that makes it 12a squared d, 12a squared d, and then ad squared, so minus ad squared plus ad squared, that cancels, ad squared minus ad squared, that cancels. So I think now everything is fixed. So yeah, this is correct. So now we have fixed it. So this gives me taking terms, taking 2 common. So k squared, or rather we can take 4 common. So k squared by 6 d cubed plus 3a squared d, and then putting in the value of k is 1 over square root d. So 1 over 6, then k squared is 1 over 2d, and then d cubed plus 3a squared d. So d will cancel out, so you are left with 1 over 12 d squared plus 3a squared. Okay, yeah, now I think it is, now everything is fine. So this is your delta x squared. So this uncertainty, now this would be square root of 1 over 12 3a squared plus d squared. So this is the answer. So now this is there in the options, and we have this as the correct option, 3a squared plus d squared over 12 and square root of that. So be very careful of the plus minus signs. So this is one lesson that we learn from this question, that one should not uh, mess up with this plus minus signs. Be very careful when you are solving the question. So this completes this week's session. We have finally managed to fix this sign issue that we had, and this completes this week's lectures on general aptitude and quantum mechanics. So next week we will again go back to mathematical physics and solve some questions in mathematical physics in the next week. So that is all from my side. Yeah, thank you very much.